when you guys are reading like a mathematical book or something like that, math books are really dense, right? Like if you go to read a book like that's not math, it might take you guys like maybe 2 minutes to read a page. Sometimes when you're reading a math book or a science book, it might take you 10, 15 minutes just to read one page because it's really dense, right? And that's the sort of thing that we want to make sure of, is that when you're reading these dense sort of texts, that you can translate them.
Did you ever do a course on real analysis?
I took one.
That's all like this.
Oh yeah, real analysis is the devil. It really is. So it was probably the hardest undergrad course I took, other than operating systems. I'll tell you guys about that another time. Okay. Let's do the other way around, okay? Let's write the sentence in a formal universal conditional statement, okay? If n is even, then 3n is even, okay? So, first of all, we have to define the domain, okay? So, for all n, what domain could even numbers be in? It can't be rational, it can't be real numbers, it can't be irrational. Integers, right? Because it could be either a positive number, could be a negative number, could be 0. Those are all possible numbers that could be even. So for all n in, and if I want to write symbolically, by the way guys, what letter represented integers?
Z.
Z. And couldn't we do this?
Positive.
Z even.
Okay.
Okay. So for all n in Z even. Okay. So if you ever see that, guys, that means you're dealing with the even integers. Okay. Then couldn't we just write the rest of it? If n is in Z even, okay, then 3n is in Z. I think when we're done with this example, what I'm going to do is I'm going to write up all the possible symbols so that way you have them in one place, okay? Because we're throwing out a lot of stuff all at one time. So I'll write them all down for you guys, so that way you just have like a library of those. Does that make sense to everybody, guys? Any questions? Not meant to be difficult. Okay. If n is odd, then n to the 4th is odd. So guys, we'd write it the exact same way, except now we would use odd. Okay. So for all n in Z odd, if n is in Z odd, then n to the 4th is in Z odd as well. Okay. Does this make sense, guys? Any questions about it? Not meant to be difficult, okay? It's one of those things where you just want to go back through a few times, make sure you're good with it. Okay. Let me just write up like a library of some of the symbols that we're going to be using, so that way you guys have it all in one place, okay? And the different sets, okay? So, and in fact, let's just start at the top, the highest place as to where a set is, okay? And let's not go past like one-dimensional. Like for those of you guys that have suffered through linear algebra, you guys know that there's like 2 or 3-dimensional matrices. Like you guys have seen R3 that have taken linear algebra. You don't want to deal with that, but there is something like that, okay? It's a vector space, if you would. Okay. So at the very top of the one-dimensional number set are the complex numbers. So whenever you see C, that is the complex, okay? Which are basically imaginary numbers as well, okay? Complex has a real part and imaginary part too, okay? Whenever you guys see R, that's a real number. Whenever you see rational numbers, okay? Does anybody know what symbol is used for rational? And obviously it's not R, because that's already reserved for real.
A.
A is not a bad guess. I'll give you a hint. It's not Z, it's not N, it's not R, it's not C. Q it is.
What, really?
Yeah. Did you just guess?
Yeah.
Nice. Do you have any reason as to why you guessed Q?
No, it's the next letter.
Next letter that came to mind. Nice. Really damn good guess. We're going to Vegas, man. Put it all in 32. All right. A rational number is the quotient of 2 integers. Quota. Okay? So Latin. Okay? So really good guess, man. Nice. Do that on the exam, you'll be great. Just guess that. No. Next thing, rational numbers are irrational numbers. We already saw that. We already saw integers, z. We haven't seen these today, but there is a set called the whole numbers. Okay. What letter would you guys suspect whole numbers to represent it by? W, and it actually is. Finally, one that makes some freaking sense. All right. And then the last set that we look at are the natural numbers.
Two questions I got.
Yeah.
Which one are the natural numbers?
Natural numbers are like your counting numbers. 1, 2, 3, 4, 5. Basically like the number of people in this room. Okay, that would be a natural number. Because if there's 0 people in the room, it doesn't make any sense.
Oh, so any number over 0.
Any whole number, any integer bigger than 0. I'll say that.
Natural.
And the whole numbers start at 0.
Okay.
That's the difference between a natural and a whole number. I don't know why they made that up, because couldn't you just say whole number minus 0? I guess that would make too much sense.
And what are
When you're using natural for the end, do you have to put the brackets?
Oh, no. That would be natural positive numbers.
Wait, I thought you just said the natural numbers.
Correct. So you never really want to write that anyway, because they're implicitly. Okay. Yeah, it was a trick. Sorry. All right. Or you were going to say something?
and what
Sorry
are
about that.
and what are these things like set? Like, are they the precedents or something? What are
Oh, these are just the representations for sets.
Oh.
So when you see these letters, that's what they mean.
Okay.
So we don't have to write out integer or irrational all the time. Okay. By the way, and for those of you guys that have taken linear algebra, there is this thing called R2. Okay. And does anybody know, or can anybody tell me what R2 is? Yeah, super R, right? Yeah. No. R2 is actually a matrix. It's a 2x2 matrix, okay? So, and we'll never use that in this class, by the way. But for some reason, and I know some of you guys are in physics and some of you guys are in engineering courses, and sometimes they represent vectors using matrices, okay? I just wanted to make sure that if you saw this in another class, that you actually get something useful out of me for once, okay? All right, so, but in our class, these are the ones I'm going to restrict those to. Okay, so does that help out a little bit? Go ahead.
So you put n plus on this.
I did, just to mess with you guys. Absolutely. Wasn't that just mean of me? You can write that on the teacher evaluation. Plays Jedi mind tricks. Yep. All right. Other questions, guys? Okay. Now that we know how to write all of these different statements, let's now write the negations of those statements, okay? And later in the course, negations are going to be just as important, if not more important, than the regular statements, okay? So, these are going to be the forms that we need, okay? So, if I have a universal statement and I want to write the negation of that statement, what I do is I flip the quantifier. Instead of a comma, I use such that. And instead of q of x, I just say not q of x. Okay, so there's only 3 things that change. You flip the quantifier. Instead of a comma, it goes to such that. And then you would say not q of x. Okay. For all x in the existential statement, again, you flip the quantifier. You flip the such that to a comma, and then not q of x. Okay? So the negations for universal and existential are actually pretty logically almost the same thing. Okay? For a conditional statement, okay, now this is the one that's a little bit sketchy. So what you would do is you flip the quantifier. So there exists an x in domain D, the comma to a such that, but instead of a conditional statement, it becomes a conjunction. Okay? With p of x and not q of x, okay? So make sure like you guys memorize those, or I'm going to allow you guys to use a note card for the examination. So it might be helpful for you guys to write these on the note card, so that way you know what the forms are, okay? Eventually we're just going to do it so many times that we're going to memorize it anyway, but for now, maybe we don't have it memorized and we got other stuff going on, so it might be good to write on your note card, okay? Let's see some examples of this stuff, okay? So how do we write these things symbolically and all that good stuff? Okay, so I'm giving you 3 sentences. One's universal, one's existential, one's going to be conditional. We're going to rewrite it using symbols, which we already know how to do. We're going to write the negation using symbols, then we're going to write the negation in an English sentence, okay? So, and this is very much like a question I might ask you guys on an examination, okay? Not a difficult question, but something I might ask. Okay. Our first statement, okay? All birds can fly, okay? Doesn't matter if it's true or not. I want to rewrite this using symbols, okay? So, how would I write that statement using a universal statement symbolically? Anybody want to take a guess? So, Art, go ahead, sir.
For all x, there exists bird, bird, right?
Okay, so for all x in
Domain,
domain, what domain?
bird.
In birds, okay, so for all x in birds, good.
Okay. Then birds can fly.
And instead of birds, use what?
X
X can fly. Very good, okay. So for all x in birds, x can fly. Okay. So that's the first part. Okay, that's not difficult. Now, I want to write the negation of this. Okay. So, it might be good for us to go back to what the negation is and just write it in the form. Okay. So, if I was to ask you guys to write the negation, you flip the quantifier. So instead of for all, there exists x in birds. Instead of the comma, you flip it to such that. And then we take the negation of the predicate. Okay? Guys, what's the negation of x can fly? X cannot fly. Okay? So it's Kentucky Fried Chicken. Can't fly. So x cannot fly. And I'm getting hungry. Nothing like greasy chicken to clog up your arteries, right? Yay. Alright. Does that make sense, guys? Flip the quantifier, comma to such that, they take negation. Okay? If I wanted to write this in an English sentence, okay? Guys, what would I say to somebody if I'm talking to a 5-year-old? What's the negation of all birds can fly? There exists a bird that cannot fly. Some birds cannot fly. There is at least one bird that cannot fly. There's a multitude of different ways you could write it, okay? I like what you gentlemen said. There exists a bird that cannot fly. Is that easy enough, guys? Not meant to be difficult. It is what it is. Okay? Second sentence. There exist engineers who are good at math. Let's hope so. Okay? So, let's go ahead and write that symbolically. Okay? So, if I asked you somebody to write there exist engineers who are good at math symbolically, okay? Somebody help me out with that and tell me what that would look like, please.
There exist
Backwards E. Okay, so we have backwards E. Mhm.
This X engineers.
So- okay. Mhm. Such that. Such that. X are good at math. Perfect.
Such that X is good enough.
Or X is good at math. Yeah. We don't lose points for correct grammar. So, X be good at math.
I'll make sure to write it like that on the.
Oh yeah, definitely. Yeah, incorporate some mnemonics into that. X holds math at gunpoint, yo. Okay, that would be useful, I guess. So, whatever. Alright. Guys, that's easy enough, right, guys? Okay. If I want to write the negation of that, okay? Somebody tell me the negation, please. What would that look like?
all engineers.
So, well, not in the sentence yet.
Engineers.
So, for
Only.
all X in engineers, good. Okay. And then such that or comma. Comma, good. X is not good at math. X is not good at math. Those are the types of engineers we don't want, right guys? That's bad. Okay. Does that make sense, guys? All we're doing, we're flipping the quantifier, changing the such that to a comma. Okay? If I wanted to write the negation in an English sentence, oh, jump on, sir.
Okay, so like all birds fly, and so the upside down A, that means that's the statement. So every single bird can fly, and so the negation would be if just one bird cannot fly, then that's not true. So that's the negation.
Right. So, and we don't care if it's true or false, okay? This statement is false, right? The first one. okay? Because not all birds can fly. But we don't care if it's true or not.
Oh yeah, I mean, like, it's contradicting.
Right, we know that this is true. I'm sorry, we know that this is false, I apologize, duh. If the original statement's false, the negation must be true, okay? So that might be what you're thinking, like, yeah, it's contradictory, so the negation must be true, okay? Is that what you were getting at, or?
Yeah, I don't mean like actually true or false, I mean, the second statement just is not the first, is contradicting the first.
Right, yeah. So generally, one or the other is true, okay? If one's false, then the other one has to be true. They contradict one another, yeah. They're never both true, okay, or they're never both false, okay? Maybe that, I think that's a better way to put it.
So like, you don't have to say like, no birds can fly, you just have to say just one, no, at least one bird cannot fly.
Perfect,
And then-
yep, that would be exactly right to his group.
Okay.
Okay, good. All right, if I wanted to write the negation of this, just using a sentence with the engineers and the math, okay? How could I write that in just a
For
sentence?
all engineers, there exists one that is not good at math.
Okay, or even more, I guess, basic with that.
There's a,
we-
All engineers are not good.
Yeah, all engineers are bad at math, okay? I think that might be good. If you wanted to write it that way, that's
You
fine,
could say all
okay?
engineers are not good at math.
Yeah, we can
That's
say that.
probably the better way.
Yeah,
'Cause you're,
that's why I don't teach English.
'cause you're not saying all engineers are bad.
Are, okay, I see what you mean, are not good at math.
Great.
They might be okay. Yeah. Like you guys might consider somebody to be bad at math if they can't take a derivative correctly, right? Somebody else might consider that if they can't add 3 plus 3 to be bad at math. So yeah, that's true. I guess that's up to each individual. Okay. All right. Let's go ahead and do the last one.
Would it be better to say